In this section, we'll be taking a look at the LDP Layer 2 Virtual Circuit Concepts objective of the JNCIP-SP exam. For more detailed coverage of this topic, please check out the Juniper courses AJSPR, JL2V, and JL3V.
In this video, we're going to take a look at LDP signaled Layer 2 virtual circuits. So the first key point to mention here is that the data plane for LDP signaled virtual circuits is exactly the same as if we were looking at BGP signaled Layer 2 VPNs. That is, the packets on the wire that are transmitted from PE to PE that are encapsulating our virtual circuit packets look exactly the same. We have our encapsulated frame, we have our control word. If this was Ethernet, that would be optional. And then we have our label stack, the innermost label indicating the virtual circuit endpoints, and the outer label indicating the LSP that's going to be getting us to the PEs that are terminating these virtual circuits. So obviously the big difference here is how we are signaling the information that refers to these endpoints. We're carrying that information in LDP rather than BGP. So let's have a walk through a very simplified diagram that illustrates how we signal this information using LDP. So again, we have our common service provider network, and we're using the same terminologies as we did with BGP signaled Layer 2 VPNs and Layer 3 VPNs. We have our customer edge devices, our provider edge devices, and our provider devices. So signaling LSPs between our PE devices, we could be using LDP for this. We could also be using RSVP for this. If we were using RSVP, we'd have to be tunneling LDP over the top of that. But we have these core signaling protocols that are providing the LSPs between the PEs that we're going to be carrying our virtual circuit traffic over. This is the same regardless of what technology we're talking about. The big difference here is that we no longer have multi-protocol BGP running between our PEs. Instead, we have targeted LDP. That's LDP that's been established using extended discovery. That is that we're immediately establishing connections between our PEs. We're not going through that multicast discovery phase. We're targeting our initial hello messages immediately at the desired PEs. And we would have a full mesh of these targeted LDP sessions between all PEs that we want to terminate virtual circuits on. And across these LDP sessions is where we're carrying the signaling information that enables us to establish these virtual circuits. That's advertising the label information that we're going to be inserting at this position here in packets when they're transmitted out onto the wire. And in LDP, you may remember, you have this concept of FEC, or forward equivalence class. And so this is basically a set of network infrastructure that has common forwarding. When we had just standard LDP alone, this would be a IP address, typically a PE loopback, and we would be associating that with a label value to create LSPs. So we have a new forward equivalence class, a new FEC, that we use to identify virtual circuit endpoints. And for this purpose, we use FEC 128. So let's have a look at what this message looks like and how it identifies the pieces of information that we need to establish a virtual circuit. So FECs within LDP are TLVs, are type length values. So the first value is the type, we're talking about FEC 128 here. So this is 128 value. It says that it's a virtual circuit FEC. We then have a C bit. This indicates whether or not we're going to be using a control word in the data plane. We then have virtual circuit type. This is going to indicate what encapsulation we have going on between the CE and the PE devices. And then we have the length field that tells us the length of the remaining information in our TLV. Group ID is not used on Juniper devices. Virtual circuit ID is going to be the number that uniquely identifies the virtual circuit that we are attempting to establish. And then interface parameters is a variable field, but it's going to contain information such like the MTU that we would be expecting on that virtual circuit to allow us to be able to detect any MTU mismatch issues, for example. So this is how we're describing the local information relating to this virtual circuit. We advertise this information in a LDP label binding message along with a generic label TLV. So in this generic label TLV is going to be the actual label value that we use for data plane forwarding. And the advertisement of this FEC in conjunction with this label TLV value is what allows us to establish that virtual circuit. And in this video, we took a look at LDP virtual circuits. In this video, we're going to talk about auto-discovery for LDP signaled virtual circuits. So imagine a scenario where you are a service provider that's supporting a very large customer who has many customer sites, and there is a very high degree of meshing going on between these different customer sites, maybe even a full mesh. The resulting configuration required on the service provider network will be very large. So there is an alternative to this, which can reduce the amount of configuration required, and that's using auto-discovery. So to use auto-discovery, we need to turn to multi-protocol BGP, and this helps us facilitate the signaling that we're still going to be doing with targeted LDP. Within multi-protocol BGP, we use the same address family that we're using with standard BGP signaled layer 2 VPNs, i.e. AFI25, SAFI65. And in it, we're advertising the PE addresses of PE devices that are connected to customer sites that we want to establish virtual circuits between. And this advertisement of participating PEs then allows us to establish targeted LDP sessions to the necessary PEs. And then we can advertise the virtual circuit signaling over the top of those targeted LDP sessions as we would normally without the use of auto-discovery. It's just that it reduces the amount of initial configuration required to do that. One thing to note that if you are using auto-discovery is that we use a different forward equivalence class to advertise the virtual circuit information over the targeted LDP sessions. We use FEC 129 instead of FEC 128. And this is a quick overview of auto-discovery for LDP signaled virtual circuits.